Hi, I'm Ken Whang of the National Science Foundation. Thank you all for coming to this session, and thanks to the organizers for inviting me to discuss an international funding opportunity in computational neuroscience. CRCNS stands for Collaborative Research in Computational Neuroscience. It's a program involving the US National Science Foundation, National Institutes of Health, and Department of Energy, and funding partners in Germany, France, Israel, Japan, and Spain. It's a broadly scoped program in computational neuroscience, including topics such as analysis of neuroimaging data and brain networks, stimulation, learning and cognitive functions, and many other aspects of computational understanding of the brain. We support collaborative research as well as projects for sharing data and other resources. The collaborations can be among US domestic investigators or international collaborations involving the US and other countries, including arrangements with several countries for parallel international funding. Roughly 30 to 40% of our applications involve international collaborations. These are reviewed alongside the domestic collaborations in a joint review process involving all of the participating agencies. If you want to apply for parallel international funding, you'll need to pay attention to the instructions for what's required from the US investigator and what's required from the collaborating investigators from Germany, France, Israel, Japan, or Spain. The US investigator needs to submit a proposal to NSF, which receives proposals on behalf of all of the US agencies. When you read the CRCNS solicitation, the solicitation instructions are on top of NSF's general guidance, which we call the PAPG. The solicitation has instructions for international proposals seeking parallel funding. If you search for that string, you'll find an itemized list of everything additional or different that is needed for these proposals. The budget of the non-US collaborators should be included as a supplementary document, not as part of the NSF budget pages. You'll find information for the non-US investigators under agency-specific information, and there's some variation here. Some of the partner agencies will require a parallel proposal. Others just need to get a notice from you that you've submitted your CRCNS proposal to NSF. You'll also find information here about project durations and whether multilateral projects are allowed, and if so, with which countries. The budget ranges for these projects are in line with other CRCNS projects, typically 100 to 250,000 per year direct costs for the whole project. All of these projects go through the same joint process of merit review involving all the participating agencies. There is not a separate review for each funder. We all work together to set up the panels and rely on their evaluations and advice for our funding decisions. Another question you might have is, what if my collaborators from a country that doesn't have parallel funding arrangements worked out with NSF? To go over the options very briefly, if your collaborator doesn't require budget support, you can have a so-called unfunded collaborator who is fully involved intellectually, and the collaboration will be responsive to the solicitation's collaboration requirement. If some financial support is essential, you can include a subaward that would go to the non-US institution with some caveats. The PAPG spells out what is required to justify US funds going to a non-US institution. And you also need to be aware that we have practical limitations that vary quite a bit across funding organizations. We might not be able to support the subaward, or there might be restrictions. You'll find more information at nsf.gov/CRCNS, including the solicitation details and information from past principal investigator meetings. You'll also find a list of program officer contacts at each agency. We can be a resource not only to discuss your project idea, we might also connect you to other funding opportunities that are relevant to your work. So think of us as a starting point. You can take advantage of the fact that we're representing 5 different directorates within NSF, 9 institutes and centers at NIH, and all of the other funding partners. I'll be glad to take any questions later in this session or by email. Thank you. Enjoy the rest of your meeting and be in touch with your project ideas and proposals.
Welcome everybody to this session. I'm Almut Kelber, Director of Research Grants at the Human Frontier Science Program, and I'm presenting you the funding opportunities of our organization. HFSP has been established 30 years ago on the initiative of Japan, and it's supported by 14 countries and the European Commission. We have a secretariat in France, and we are supporting science which in a way that is different from many national funding agencies. The key aspects of these specificities are the following. HFSP funds basic life science research on all levels of organization, so ranging from molecular and cellular level to complex biological systems, including cognition, ecosystems, and others. It's funding cutting-edge research which is extending the frontiers and transgressing the frontiers of life sciences, and therefore no preliminary data are required in applications. The research is investigator-driven. There are no specific areas which we prioritize because the frontiers are changing so rapidly. The competition is fierce. It's a very low success rate, but those who get funded have a really good time doing their research. The emphasis is really on scientific merit, the participation and inclusion of scientists from disciplines outside the life sciences, new lines of research, and in really short words, international, interdisciplinary new collaborations. There are two schemes, the postdoctoral fellowships, which come in two flavors. The long-term fellowships for applicants who've done their PhD within biology, biomedicine, which do a new project in a different field, a different country, and a frontier project. And then the cross-disciplinary fellowships, which are for applicants from other sciences outside the life sciences, like physics, mathematics, to work in frontier life sciences. The deadlines you see are in May for this scheme, and you can look it up on our homepage. Second, we offer research grants, and these are grants to teams of 2 to 4 scientists. There are two sub-schemes of the grants program. The so-called program grants for teams of scientists at any career stage. Very often there are young scientists involved. These teams have to be international, preferably intercontinental, interdisciplinary, and they have to work on new research topics for each team member. And there are the early career grants, where everything said above is valid, but all members have to be within 5 years after obtaining their first independent position and within 10 years after obtaining their PhD. For these grants, the deadline is in March, and you will be able to look it up exactly on our homepage. Just as important as knowing what we do fund, it's important to know what we don't fund. We do not support projects that are just routine grants, continuation. We do not fund applied and translational research, clinical, pharmaceutical, including human participants, diagnostics and therapy development. We do not fund applied technology or applied engineering. We don't fund any kind of environmental, ecological research. And we also don't fund just observational studies or studies aiming to collect large data set, like a lot of omics studies which don't ask functional questions. Research in non-profit environment can't get funding, but such people can collaborate in teams with university or other institutions. Importantly, we don't fund a continuation or the next logical step in any of the applicants' ongoing work. It has to be a new program for each of the applicants. And we don't fund already established collaborations between teams. So it has to be a new team set together for a new interdisciplinary project that aims to answer an important fundamental question in life sciences using a new way to study. If you have more questions, you can contact us via email. I give you the addresses of the Research Grants Office and of the Fellowship Office. You can look up our homepage, which has all information, and you can sign up for the newsletter HFSP Matters. With this, I'm happy to also answer questions and welcome to apply for grants from HFSP.
Hello, my name is Pawel Swieboda, and I'm the Director General of the Human Brain Project and CEO of eBrain's research infrastructure. I'm truly delighted to speak at today's OHBM Roundtable, and I'm very much looking forward to the discussion. In my introduction, I would like to focus on data and on three preconditions that, in my view, are necessary to make data the real game changer that we all hope it will be. In brain research. We all hope that it is in data where the breakthroughs of the future reside. But the three preconditions are, first of all, benefiting from the scale of data which is today available. And that necessitates sharing. Sharing needs to be incentivized. It needs to be incentivized through the funding programs, but also through the development of new standards, new data formats. Researchers themselves need to feel the attractiveness of sharing, because after all, it is at the end of the day, researchers' own decision to share data. So they need to find the idea of sharing much more attractive than they do today. So that's the first point. The second point is that we need to extract much more value from data. The way we approach this in the eBrain's research infrastructure is by offering a range of services to the research community, from base infrastructure, supercomputing and HPC facilities, onto data management and curation, and onto the more specialized and personalized services such as modeling and simulation. It is in that entire experience that we hope to address scientists' real research problems. What we offer is high-level support, and we offer personalized workflows that we can adapt to each researcher's scientific question. Let me add at this point that also our tools are co-designed with the scientific community. So we very much hope that they are best positioned to answer scientific needs. My third point is that the data game-changing moment is very much a function of its responsible use. Data needs to be used responsibly, and that means in line with the privacy regulations. And in my personal view, it is entirely possible. We are seeing federated technology for federated analytics of data, which achieves very spectacular results while being entirely compliant with some of the strictest privacy regulations, such as the ones we have in Europe or in Japan and in other places in the world. So we need to invest in the federated analytics to make the range of tools available to researchers much better suited. And it is these three conditions, which in my view will constitute a step change in the way data is used. And I very much look forward to discussing it now in the roundtable. Thank you.
What is MSCA? The Marie Sklodowska-Curie Actions are the European Union's reference funding program for doctoral education and postdoctoral training. They support researchers from all over the world, in all scientific domains and at all stages of their careers. They equip researchers with new knowledge and skills and encourage their mobility between countries, disciplines and sectors in and outside academia. They offer attractive working and employment conditions. The MSCA also contribute to developing excellent doctoral and postdoctoral programs and boost research collaboration worldwide. They increase the global visibility and attractiveness of organizations. By supporting innovative research, the program contributes to finding innovative solutions to the challenges faced by our societies. The 5 MSCA actions. Whether you are an individual researcher, an organization, or a staff member, the MSCA has something for you. Through its doctoral networks, the MSCA enable academic and non-academic organizations to collaborate and create excellent doctoral programs with a strong international dimension. Doctoral networks include industrial doctorates, which allow PhD candidates to train beyond academia, and joint doctorates, which deliver joint training programs and degrees from several organizations. Doctoral networks provide creative and entrepreneurial doctoral candidates with research-related and transferable skills and a focus on open science and innovation. Through the postdoctoral fellowships, researchers can develop their own research proposal with the host organization of their choice. This allows them to pursue their research and follow advanced training with leading organizations in their field, acquiring new and transferable skills in academia or in the non-academic sector. Researchers can choose between European fellowships or global fellowships, enabling them to gain international experience either in Europe or somewhere else in the world. Under Co-Fund, an organization can get co-funding for its own doctoral or postdoctoral programs at regional, national, or international level if it follows the excellence principles and working conditions of the MSCA. Co-Fund promotes excellent training and career development for researchers, thus spreading MSCA best practices to new or existing schemes. Through its staff exchanges, the MSCA enable organizations to exchange research and innovation staff worldwide in the framework of joint projects. This includes researchers, as well as technical, managerial, or administrative staff. Staff exchanges allow knowledge transfers among disciplines and between academia and the non-academic sector. Finally, through the MSCA and Citizens Initiative, organizations can bring research closer to the public by organizing activities and events during the European Researchers' Night. By doing so, they highlight the role of research for society and the economy, as well as the impact of researchers' work on citizens' daily lives, raising young people's interest for research and scientific careers. Marie Sklodowska-Curie Actions.
I'd like to thank the organizers for this opportunity to represent the NIH Brain Initiative at this funding roundtable. The mission of the Brain Research Through Advancing Innovative Neurotechnologies, or BRAIN Initiative, is to revolutionize our understanding of the human brain by accelerating the development and application of innovative technologies. This initiative was announced by the White House in 2013, with first awards made in 2014, and represents a partnership between 5 U.S. federal agencies and private foundations. Now, the NIH efforts have been guided by 2 strategic plans, first issued in 2014, the BRAIN 2025 report, and a revisit of this plan in the BRAIN 2.0 reports that were issued in late 2019. The goal here is to develop and apply new tools for understanding how neural circuits underlie complex behaviors in health and disease. And to accomplish these goals, it is important that we leverage emerging technologies to enable new discoveries about neural circuit function, to use these discoveries as a foundation for new therapeutic strategies for human brain disorders, and very importantly, to disseminate and democratize these technologies for basic discovery as well as for clinical applications. The NIH Brain portfolio is organized across 8 main themes or areas, and again, which are in turn managed by 8 project teams. So these are in order. Team A covers brain cells and circuits analysis. Team B covers neural recording and modulation technologies, as well as invasive human studies. Team C covers human non-invasive or minimally invasive neuroimaging and neuromodulation technologies. And Team E covers the understanding of neural circuit function, as well as the theory underlying neural circuit function and behavior. We have 4 cross-cutting teams that cover the areas of training, inclusion, and equity, dissemination of brain resources, neuroethics, as well as informatics. Now, members of this audience here might be particularly interested in our work in supporting human non-invasive neuroimaging and neuromodulation technologies, and the team leads here are Drs. David McMullen and Shumin Whang. So I just want to draw your attention to 2 funding opportunity announcements in this space, in the human brain imaging space. The first is proof of concept development of early stage next generation imaging technologies. And the second one here listed below is development of next generation human brain imaging tools to scale up these tools for eventual dissemination into the field. I should say that we welcome applications from international scientists and collaborators. Please contact Drs. McMullen or Whang if you have questions about these RFAs. The receipt dates are next due on September 3rd, 2021, and a complete list of funding opportunity announcements can be found at our website here at braininitiative.nih.gov. Now, I just want to finish up by highlighting Brain's strong belief and our upholding belief that we will do better science through a diverse workforce. And to this end, we have a number of workforce development programs in the training space here, diversity supplements, K99R00 awards, as well as an F99K00 transition from pre-doctoral to postdoctoral funding support. Again, I encourage you to look at our website for more information about these mechanisms. We are also supporting capacity building and dissemination across the country, not just at the elite institutions. And here we have a new U24 mechanism for standing up reagent resources at minority serving institutions and IDEA eligible institutions. And then finally, we have just started incorporating into new funding opportunity announcements a requirement for a plan for enhancing diverse perspectives, where we will now be asking for applicants to describe how their diverse team will support better science that is being proposed. Finally, there are a number of conferences I should draw your attention to. We just concluded a series of workshops on non-invasive imaging. The workshop is past, but if you go to our website, you can find the recorded videocasts available for viewing. Upcoming are circuit therapies workshop, as well as our annual Brain Initiative Investigators meeting. And I should say that this meeting is open to all who wish to participate. You do not have to have brain funding to join. So I encourage you to sign up and enjoy and participate in that meeting. And finally, you can find more information about the Brain Initiative at our website and also be up to date with the goings on at the Brain blog. So thank you very much, and I look forward to this discussion.
My name is Tetsuya Matsuda, a program officer for Japan Brain Minds and Brain Minds Beyond. Thank you very much for inviting me to this roundtable. I will introduce the National Brain Project of Japan, Brain Minds and Brain Minds Beyond briefly. Brain Minds and Brain Minds Beyond programs are 2 large-scale brain science projects of Japan. While Brain Mind focuses on studying the neural circuit in marmoset to gain new insight into the healthy and diseased human brain, Brain Mind Beyond concentrates on translating that knowledge into human brain sciences. 2 new brain research programs are starting this year, focusing on molecular research in basic and clinical neuroscience and researches using data sciences. These programs are planned as complementary to already existing Brain-Mind and Brain-Mind Beyond, and recruitment of young researchers is a priority here. Through this project, Japan is very open to international collaboration in aspects like marmoset databases, human MRI databases, and so on. Next, I'd like to give a quick introduction to the Brain-Mind Beyond, the Strategic International Brain Science Research Promotion Program, also known as Brain-Mind Beyond, was launched in 2018 June as a 6-year project under the Japan Agency for Medical Research and Development. It is a partner project of the Brain-Mind Japan. The program aims at revealing human intelligence, sensitivity, and sociality at the brain circuit level for the early detection and intervention of psychiatric and neurological disorders. Brain-Mind Beyond is an initiative to contribute to the fight of the brain research globally by enhancing collaboration with the domestic projects of other countries across the world. I have already mentioned Brain-Mind Beyond aims at revealing human functioning at neural circuit level. To achieve the aim, it's fostering comprehensive analysis of brain images from healthy to diseased states, comparative study of neural circuitry of human and non-human primates, and developing AI-based brain science technologies. In this program supervisor and program officers help supervision of the effective utilization of the competitive fund to ensure remarkable success by the researchers of the Brain-Mind Beyond. The National Institute for Physiological Sciences work at the administrative hub of this program. Brain-Mind Beyond is in the 3rd year of its course. However, I'd like to briefly state the major focuses of research group and approaches. One of the focuses is establishing and public release of human brain MRI database consisting of longitudinal brain MRI from different life stages, both diseased and healthy individuals, as well as data from interventional research. The study along the life stage focuses on the longitudinal analysis of cerebral images from healthy to pathological states by life stages. The study in disease intervention focuses on the elucidation of neural circuitry to accelerate research for early prevention, diagnosis, and intervention. This study focuses on Parkinson's disease, mood disorders, epilepsy, eating disorders, and ADHD. To achieve the goal of this huge endeavor, we are actively promoting the harmonization of multi-site multi-disorder MRI data as well as sharing them with international collaborators. The harmonized protocol have got published in 2020. Moreover, we are also developing data sharing framework for domestic and international collaborators, which includes opening of the Brain-Mind Beyond data portal site, creating the Brain-Mind Beyond human MRI data sharing policy, and so on. We hope this database will be a valuable tool in the advancement of brain science research not only in Japan but also across the world. Another important focus of Brain-Mind Beyond is to do an interspecies comparison of human and non-human primate brains by structure and functional regionalization and phonology analysis. 3 research groups are working here with themes like elucidation of pathophysiology of psychiatric disorders and mechanism of plasticity at the network level, understanding the brain function, architecture, and connectivity related to sociality and brain diseases, cross-species comparisons of network dysfunctions and behavioral deficit. Brain-Mind Beyond also focuses on the development of AI-based brain science technologies, and 2 groups are working under this topic. While one group is focusing on the development of AI-based diagnostic and therapeutic technologies, another group is working on next generation AI to develop fundamental technologies. More specifically, we hope to develop variable tools like biomarkers, neurofeedback technologies, and innovative brain type algorithms here. Japan is looking forward to working collaboratively with the brain science communities across the world. Thank you for your attention.